Ants are among the most resilient and adaptive insects, with remarkable strategies to survive and thrive even in the harsh and unforgiving desert environment. Deserts are defined by their extreme temperatures, limited water resources, and scarce vegetation, posing significant challenges for survival. Yet ants, with their exceptional adaptability, have evolved behaviors, physiological mechanisms, and social structures that allow them to endure the hardships of desert life. These insects can be found in deserts all over the world, from the arid regions of North Africa and the Middle East to the American Southwest and Australia. Each species of desert ant has developed unique methods to handle the challenges of high temperatures, scarce water sources, and limited food availability. The way ants live in deserts is a fascinating example of nature's ingenuity and the power of social collaboration in ensuring survival. One of the most pressing issues for any creature living in the desert is the extreme heat. Temperatures can soar above 50 degrees Celsius, 122 degrees Fahrenheit, during the day, making survival almost impossible for most animals. However, desert ants have developed a variety of behavioral adaptations to avoid the worst of the heat. Many species are nocturnal, foraging and performing activities only at night when temperatures drop to more tolerable levels. For instance, species like the honey ant of the American Southwest have evolved to be active mainly during the cooler hours of dawn or dusk. By limiting their activity to these times, they reduce the risk of overheating and conserve energy. Some species, however, take an opposite approach and forage during the hottest part of the day when predators are least active. The silver ant, Cataglyphus bombacina, found in the Saharan desert, is one of the few species capable of foraging during the peak heat of the day. These ants can withstand body temperatures of up to 53 degrees Celsius, 127 degrees Fahrenheit, due to the unique physiological adaptations. The silver ant's body is covered in tiny, reflective hairs that reduce the amount of heat absorbed by the sun. By reflecting sunlight away from their bodies, these ants can tolerate the searing temperatures of the desert sand. Additionally, they move at rapid speeds and take the most direct paths between their nests and food sources to minimize their exposure to the sun. In addition to behavioral adaptations, desert ants have physiological mechanisms that help them retain and conserve water, an essential requirement in a habitat where water is in short supply. Desert ants have a waxy coating on their exoskeletons, which helps to prevent water loss. This coating reduces the amount of moisture that evaporates from their bodies, enabling them to retain more water and survive longer in dry conditions. Furthermore, desert ants have specialized systems for managing their water use. For instance, some ants have developed the ability to metabolize water from the food they consume, allowing them to obtain moisture from sources that would otherwise be considered unusable. One of the most fascinating examples of water conservation can be seen in the behavior of honey ants. These ants store nectar inside the bodies of specialized workers known as repletes. Repletes gorge themselves on nectar and store it within their abdomens, which swell dramatically as they become living storage vessels for the colony. When water or food resources become scarce, other ants can access this stored nectar by feeding from the repletes. This strategy allows the colony to survive through prolonged periods of drought, as they essentially create their own reserves of food and water within their nest. Desert ants also face the challenge of finding food in an environment with limited vegetation and animal life. Their diet is highly adaptable and varies widely depending on the specific species and the availability of resources. Many desert ants are omnivorous scavengers, feeding on whatever they can find, from dead insects and seeds to small invertebrates. Some species have even developed specialized hunting techniques that enable them to capture live prey. For example, the desert harvester ant, Pogonomyrmex spp, is known for its seed harvesting behavior. These ants gather seeds from the surrounding area and store them in their nests as a long-term food source. They are incredibly efficient at locating seeds, and their nests often have large underground chambers where seeds are stored in case of famine. Social structure is another critical factor that allows desert ants to thrive. Ant colonies are highly organized social systems in which each individual has a specific role, such as worker, soldier, or queen. This division of labor is essential for survival in the desert, where each task must be carried out efficiently to conserve energy and resources. Workers are responsible for foraging, nest maintenance, and caring for the young, while the queen focuses on reproduction. By specializing in specific tasks, ants can maximize their productivity and adapt to the changing demands of the environment. The nest itself plays a significant role in the survival of desert ants, providing shelter from the harsh climate. Ants construct elaborate underground tunnels and chambers that remain cooler and more humid than the surface, protecting them from extreme temperatures and reducing water loss. The depth and structure of these nests vary depending on the species and the specific desert environment, but they are generally designed to maximize temperature regulation and air circulation. For example, some species of desert ants build nests with narrow, vertical shafts that capture the cooler air from deeper underground. By creating a stable, controlled environment within their nests, desert ants can provide a safe haven for the colony during the hottest parts of the day. Desert ants also exhibit cooperative behaviors that help them survive as a collective. For example, if a food source is discovered, ants communicate its location to other members of the colony using pheromones, chemical signals that other ants can detect and follow. This form of chemical communication allows the entire colony to work together to exploit food sources efficiently, ensuring that resources are gathered and shared among all members. This cooperative approach is essential in the desert, where food is scarce, and each opportunity must be maximized. The life of a desert ant is not without its challenges, and survival requires constant adaptation and ingenuity. In the face of a hostile environment, ants have developed a combination of behavioral, physiological, and social adaptations that enable them to thrive. Their ability to work together as a colony, communicate effectively, and use the limited resources available to them has made them one of the most successful inhabitants of the desert. From the unique reflective hairs of the Saharan silver ant to the intricate food storage methods of the honey ant, desert ants exemplify the remarkable diversity of strategies that nature can employ to overcome environmental extremes. The resilience of desert ants is a testament to the power of adaptation and cooperation. By evolving strategies that allow them to avoid heat, conserve water, find food, and defend themselves against predators, desert ants have managed to carve out a niche in some of the most inhospitable regions on Earth. Their success is not just due to individual survival skills but is a result of the complex social structures that allow them to thrive as a collective. These ants are not only survivors but are also a vital part of the desert ecosystem, contributing to the health and balance of their environment by scavenging, dispersing seeds, and serving as prey for other animals. The story of desert ants is a fascinating example of how life can persist and even flourish in the face of seemingly insurmountable challenges, revealing the intricate connections that bind all living organisms to their environment. Thanks for watching. Subscribe for more.